Thank you, Ahmed, for the introduction. Thank uh, thank you, OBA, for hosting me today, and thank you, everyone, for yeah for coming today. Uh, let's firstly check the voice and sharing is okay.
Yes, your voice and the camera are clear, engineer.
The screen I didn't share it, right?
No, it didn't appear yet.
Okay. Okay, I think all good now. So let's close the camera to make you focus on the slides. Yeah, today we will go through together one of the topics related to well logging. It's kind of like specialized in well logging, uh, but one of the important aspect of well logging. And I'll reveal in terms of oil and gas because this is my area of expertise. There is some other applications of borehole imaging and borehole camera in in some other aspect, but my focus today will be regarding oil and gas. So we will try to make the floor harmonized for everybody, as we might have different backgrounds here. If you want to share your background on the chat board, so it would be nice. So yeah. So we will talk about the applications of borehole images in different sites, mainly geologically. So how to see not just like processing or interpreting images. We will try to to read the geology out of the borehole image, if we can say. So what geological, so let's deal with it as the image will tell us a lot. So will tell us like a comprehensive story about subsurface and reservoir. In the upcoming slides, we will speak in not in a very detailed manner, but in a simple way and more illustrative way, to see how the borehole image can tell us about stratigraphic aspects, structural aspects, different sedimentological information, diagenetic information, porosity, and else, which overall will serve how we can, know about the reservoir quality and understand at the end. So, where is the sweet spot, and where is oil and gas, and where is the good base zone, or the good oil zone. So this is our main. So yeah, well, from aspect to aspect, and then integrating a lot of info together to get a final look, maybe about the depositional environment interpretation and else. I think when we talk about borehole images, or you search about borehole images, definitely you will find something like this. So yeah, a borehole image, if you write like FMI, so FMI is a tool, one of the famous tool, I mean, for borehole images, but yeah, people got used to call any kind of borehole image as a FMI. FMI or dip meter, some people also call it dip meter. This is this I mean this photo or this capture here is a real case for fractures. I would say fractures maybe come in the first I mean the first spot in terms of borehole image utilization. Do you it would come like in the first spot in terms of borehole image utilization. I mean uh, yeah, I think yeah, maybe most of the operators and most of I mean uh, I mean people use or run the borehole image to understand the fracture criteria. There is a lot of applications, yeah, but I think yeah, maybe one of the most common. I mean, so to see the fractures. Fractures, it's like yeah, weak planes or open planes in the rock. It might be related to, I mean, mechanical criteria, depositional criteria, not very common, and also the most common tectonic criteria, appreciation and tectonism. So it can, I mean, inherit a lot of fracturing as well. So usually dominant in carbonate. I mean, as more as we have like a brittle rock or a brittle block, we will see fracturing. And when this fracturing underwent, I mean, tectonic episodes or faulting or else like deformation, it will, I mean, the rock itself will exhibit like fractures or fracture network or fracture corridors. Fractures, it's like two-edged weapon in, I mean, in the oil production. So sometimes it's, or in a lot of times, it's important that it will enhance the porosity and permeability. So we're good to, I mean, to identify the fractures and see how it looks, the orientation and the nature of the fracture, whether it's, I mean, it's open or closed, and so on. And also it might be like sealed or I mean closed fractures. So yeah, FMI or borehole image is important tool. It come in the first, I mean, the tool to, I mean, to identify these kind of rock behavior, which is the fracturing here, to understand where is the fracture zone. Another thing, I mean, the fracture itself, it can be impacting the reservoir. I mean, it sometimes, especially in horizontal wells, and then when we have like kind of like vertical or semi-vertical fractures, and the fracture is I mean, it can be extended to I mean a water level, so it can like make a water breakthrough and impact the reservoir production by increasing the water cutoff. So in this case, we don't want to see this kind of fracture. And then the previous case, which is dominant one, we need fractures to have more, I mean, optimized porosity and permeability for our reservoir. When we see the image, so let me start using the pointer now. Usually we will I mean see this I mean circles and tails, this pins, yeah. So this is we call it tadpoles. Tadpoles, it represent the dip magnitude and dip azimuth. So dip magnitude is the amount of dip, and dip azimuth is I mean is the direction of dip. So in case of the fractures, we we might care about the strike azimuth itself to see like the corridors, I mean, or the fracture trend, how it look like. So usually you will see image like this, and you will see like these kind of sine waves or sinusoid. So usually we trace the fracture here. So this is unfolded view of the well bore, and then we will start seeing. And then when we trace it, we will start pop up the amount and direction of the. So yeah, this is not only for the fractures. It's for any traceable features that can be picked or identified from the well. We didn't have I try to put some slight effort to put like a definition for what is borehole image. So, but yeah, borehole image, it's not like a direct camera for the well bore, but it's trying to map a property, certain property around the well bore. So we will have kind of like mapping each side of the well bore. Usually, the most common dominant property we use for the borehole image, which is the resistivity, or we say electrical. So yeah, for example, if we have like tens or hundreds of curves of the resistivity, around the well bore, then we will have like normalized process. Normalized image with colors, and you will see what you see. So yeah, this is simply what is borehole image. And usually the electrical image or resistivity image is like wire line, which is the dominant one in terms of resistivity or electrical. The others is mainly in the LWD side. So a lot of applications for borehole image. Geology is two aspects. So stratigraphy, or sedimentary, and structures. So as we mentioned, that we try to read the story, to read like a geological story from the well bore, like having a real capture of subsurface. So we will see the structural depth. How is the structural depth? To understand the structural framework, we will see fractures, as mentioned. We will see faults, folds, and conformities. If you are all geologists, so I would expect that you know these terms. Like this is kind of like geological alphabet, so it's well known for. But if you have any questions, so at the end of you can just like ask me. And the other side, the sedimentary features, we can have different kind of sedimentary depths, starting from the regular or conventional bedding, then a lot of primary structures like cross bedding and different types of cross bedding. And hence we will identify what's called value current analysis, like to identify the direction of the deposition of the sand. So this is what is value current direction. Like when we have a river or a stream, then we will know from the source and from the source and the direction of the deposition, and then we will like kind of expect the increase of the sand dumping in which direction. Also, a lot of of primary structure and rock textures, it can be, I mean, identified from from the borehole image. So yeah, I cannot count how many sedimentary structures we can see because or primary. So because there is a lot, a lot. Yeah, a lot of bidding behavior we can see, and also a lot of, I mean, size textures we can also have it from the borehole image. Not only primary and secondary as well. So like yeah, cavities, vugs. I mean all the like the solution channels. I mean vagular cavities. All these kind of like diagenetic features. So it can be also identified, especially for, I mean, if we talk about for carbonate reservoirs or choke or else. Yeah. The the bidding is one of uh, the first thing, I mean, we look at, or we by nature we start picking the bidding when we have like a piece of FMI or a piece of borehole image. Yeah, because the bidding will give us, I mean, this is the structural language. So we want to understand where I mean these structural zones, or I mean the this blocks is dipping in which direction. So, and this is very important, and the only tool that can give you this from logging, which is the image. So to know dip information, dip magnitude, and dip azimuth. So we usually get it from shale bidding, but I don't recommend to spend like, I mean, too much. I mean, millions of bidding and like picking. So the idea is to pick the representation of the structural dip. So and bidding, it's the layering. If you see any outcrop, so here in the deck you will find like this is how the layers will look like in a geological outcrop. So we can have 2, 3, 4 millions of layers. So if you are, for example, picking shales, or if, for example, you have like lamini, or I mean, like a lot of facility planes, and so you'll find like a lot of these, like the gradation between sand, I mean shale, silt, and then shale again. In I mean, in especially in the clastics, so you will find a lot of these. So picking, I mean bidding is important to I mean the first quick look to understand the structural depth, and then this kind of a structural depth, it will fulfill or it will be integrated with the seismic dip as well. So seismic is good, but it's a coarse resolution. So the resolution is coarse. And here, so when we have it from FMI or from dip meter or from these kind of tools, it will calibrate what we already saw in the, I mean, in the seismic line. A lot of brochures. Anybody who's trying to understand, to read about borehole image, or you will see this kind of like figure or this kind of photo, which is like crystal clear, the fault appearance here. Yeah. Yeah, it's also very good info out of the borehole image we can have to have idea and to have information about the fault or the faulting, or I mean what happened in terms of tectonic deformation. In the picture you see, this is not a big fault. This is like baby fault or dwarf or small fault. But it can range. So you can see a lot of scales of fault. Sometimes it can be captured in the borehole window. In the borehole window look that you see, and sometimes we can see see like a plane, and then using integration from the dip data and the change or the log motifs, so we can confirm that we have like a fault area or like a fault zone. Sometimes we have drag pattern related to the fault. Drag pattern, like you will find like a severe or a good contrast in dip above and below this kind of a change, so then we can identify the fault. So geologically important to understand the strike of the fault, the dip of the fault, which direction this fault is dipping. We have from the image we can have the true dip, and then the strike is the true dip is perpendicular to the strike of the true dip is perpendicular to the strike. So in this case, for example, if this if this fault is striking, is the strike is north northeast south southwest, so then the true dip it could be east southeast, or it could be west north west. And simply we can identify this from the pic. So this is just like from this rose diagram, but it's easily when you just like put here, so we can see this trough. This is indicate the direction of dip. So in this case, this is it's dipping toward it's around here. This is between 285 and 315. So this is almost so here toward this direction. So now we can know that this is dipping in this direction.
Engineer,
Hello.
hello, يعطيك العافية. Engineer, can I ask if the borehole image can show us يعني other than the fault, maybe we have مثلا anticline or salt dome or maybe a dike?
Good question. Let's firstly think about the scale of the feature.
Yes.
Yeah. So when we talk about salt dome, so we are talking about like mega scale, right?
Yes.
So this is the first thing. So here we are dealing with a borehole scale. So borehole scale, usually like the most common borehole scale, maybe 8.5 inch. You can just 8.5 inch is just like you can make it by your hand, so it's easy. Or
Yes.
12 and a quarter, and the smallest one, which is also it's 6, but the most common is 8.5. So you can just like use your hand, narrow it to each other. So now you will understand how this is just like the diameter of your face, kind of. So this is like a small scale, but there is some kind of further analysis. So when we pick, the dip. For example, let's how we use. So, for example, if we have something like this, and we have crossed the well crossed. So maybe from dip data, we will see some dipping like this, and this, some kind of dipping like this, with some change for definitely in the dip. So now, so if we cross some layers, so from this picking, we can get an idea about what happened in I mean in this mega structure, especially if we have kind of like overturned folding or what they call it, yeah, it's overturned, yeah. But in other cases, if we have like a fold like this one, and we crossed here in this area, we might just, so yeah, we will just see like dipping in one direction. Sorry for the graphics, so but I'm just trying to make it like to get the idea. So
Yes,
yeah, did you
but
get my idea? So
thank you.
you're welcome. Yes. Hmm. Back to sedimentary, to stratigraphy. If you know what is cross-bedding, cross-bedding is number one sedimentary features revealed by sand dunes or sand deposition. It's very common in sand deposition, that the sand, when it's, if you search in the internet, you will find millions of animations and videos about how the dune migration is. So important for us here when we deal, as we, most of our reservoirs, or yeah, either sand or I mean carbonate and some others, but yeah, the most dominant. I mean, so when we talk about sand, it's important to understand how is the internal texture of the sand, and how is I mean the dip the dip behavior of the sand. So when we have a tool that that give us like a millimeter scale of these small laminae that you see, that which is like came by the deposition, yeah, the deposition of the sand. So when you have like sets and then another set, so like when you have a sets of like sand like this, and then when you get a cross section, you will start see what you see here. So the idea of having this is to pick these kind of like sand textures or sand cross-bedded. We call it cross-bedded sand sets. The separation between each set, we call it, I mean, bounding surfaces or reactivation boundary, and then another set. So we have a set and then reactivation or set boundary, and then have another set of sand, and so that's why it end up by sets of cross-bedding. So the important for us when we pick these, I mean, when we identify the depth criteria of these, I mean, of these sand sets, we can determine how is the direction of the sand. So, and it's why we want to understand the direction of the sand to know where is our sand is increasing. So for, I mean, for potential drilling, we will drill in the increased direction of the sand, and also to know where is the flow direction. So yeah, borehole image, it's a good tool to reveal such of cross-bedded sets, and hence as well, this will be I mean, like, it will fill a lot of information if we start build the positional model. So when we build, because you don't have an option either to get these data from core. The thing about core is the core is good because core you have a real piece of rock, but but you can imagine how much cost of the cost of the core is not small. It's big cost. Also, the timing of core in the operation itself, it takes time, and also the recovery of core is not it's very challenging as well. So you are not 100% sure to get the full recovery of core or no. And another also challenge with dealing with core is the orientation as well. So if there is misorientation, then it will impact all the interpretation out of of these core plugs or of these core interpretation. This texture is not clastic texture. It's non-clastics or carbonate textures. Vugs is simply open holes or open mesh or like holes in the rock. So usually it happened by diagenetic action, like solution and dissolution of calcium carbonate, magnesium carbonate, and else. When these all the dark appearance you see in the image, usually if it's open, which is the most dominant, it will be the impact of the mud. Why? Because we usually when these holes or cavities filled by the drilling mud, which in this case usually water-based mud, which has a conductive nature. So you will see this kind of electrical image will have like resistive and conductive, and in this case the conductive will represent the mud filling of these cavities, and this mud filling we will kind of like trace it, and then we will identify that this area is a weak area, and a weak in terms of rock alignment or rock. It's like it has a lot of cavities, and then it has a lot of secondary porosity. So this secondary porosity, when it's taken into account, it will add a lot in the formation evaluation or in the porosity calculation as well. So image is a good tool as well. To give such piece of info about such cavities that we have. And nowadays with the smart solution of AI and the automation, I would expect that there will be a big advancement in mapping these kind of like tiny spots out of the image to get some some adding reserves or adding porosity that was previously or conventionally ignored before. As I mentioned, there is a lot of texture criteria and a lot of texture elements. So it's not easy to count, every rock texture. So you will see. But as we're dealing with, an image of the hole or image of subsurface, we will see a lot. So like grain size change. So this is kind of like nice capture of real capture of area of like change in grain size. Even you can, and also as I mentioned with the current capabilities of AI tools and we can get a lot of info about the size, the change, the backing, sorting, and else of these. Of these changes or on the grain size or the grading of the grain size. So I think in a one look now you can see like the grain side and then the matrix and then even the cement or the framework in between. So yeah, you can draw it even. So this is important. Maybe in terms of reservoir quality, this is not good reservoir because it's like poorly sorted. I'm not quite sure to be honest, but maybe it's not that good reservoir or because it has a lot of changes. So maybe but at least you will get a lot of information even about the depositional environment and maybe this is alluvial fans or rain wash or so then you can start make a geological story out of like 1.5 meter you have. Bioturbation, this is not well common to everybody, but see how the capability of such tool to the bioturbation it came from bioorganic or whatever bioorganism. So bioturbation is when turbation is kind of like disturbance or burrowing or pouring and burrowing, and if you remember from the university classes, so mold and cast and these kind of like paleontological terms. So when you have like bioactivity, then can be reflected also. Sometimes it need a smart eye to get it, but with experience you can trace it and you can identify it. Why it's not a fancy thing to identify bioturbation, but it's important because also it impacts the porosity. Usually bioturbation can destroy the porosity because it can bring if it can distract the uniformity of the bedding, and it can usually, and in some other cases it can create porosity. So this is also will directly impact the reservoir quality and porosity estimation. So it's good to have a kind of like aids for mapping such changes. Some other applications, there is a lot of application, but some others we can consider it a little bit advanced. So not too much, but so in terms of borehole shape, there is a well-known changes in borehole. It's either drilling induced fractures or borehole breakout, and I'll show examples for them. And this is where it's also image is the most important tool identifying these kind of like borehole deformation features. So for geomechanics, evaluation and geomechanics study, this is a good input for mechanical earth models. So, and hence, see how the mud window it will be, and any further subsequent mud weight selection. Usually also image can be complement for core analysis as mentioned due to cost recovery and also, or it can also used as a guide for having sidewall cores and getting like core sidewall core plugs, and so we can identify the zone of good. So at least not like coring everything, but at least we can identify some sweet spots, potential zone, and then right away start coring. So and also the getting the pressure point. So XBT, MDT, I would say looking into FMI or borehole images is for me is a must. So if you have it, so it's a very recommended to have a look. Yeah, with the team or whatever. So to see which zone you're gonna, I mean, select if you have this option. So if you have the tool, if you have the image. Yeah, and in the I mean in the main workflow, all these information will be direct input to have a good geological model. So I mean the structure, stratigraphy, all the aspect related to reservoir architecture. So all these kind will be like building stones, good, and it will be very important for optimizing I mean the geological model or whatever for example, the porosity. If we talk about the property model, the porosity and permeability models, for example, if we having like secondary porosity, I mean data. So this is, I mean, regarding the drilling induced fractures and breakouts. So simply, yeah, it's both of them are failure or deformation in the borehole. We are not talking about geology now. This is not geological features. It's borehole features. So the term in drilling induced fracture, from the wording itself, it's a fracturing, and breakout, it's just like an area collapse or area change. So usually drilling induced fracture is perpendicular to the maximum horizontal stress, and the borehole breakout, it's appear in kind of like a weaker one, so which is the minimum horizontal stress. So this is more like shear failure. It's like kind of shearing. And the fracture is here is like when you break something, it's a breaking action. So it's more of tensile failure. So this is how the induced fracture, it will appear as like parallel or semi-parallel lines in the image. And the breakout, it will appear as like dark area, also in two sides 180 degree apart. Both of them will be 180 degree apart, and usually will both of them, I mean, they will not have it will have breakout will be, for example, in this size, and or induced fracture will be in this side, and then perpendicular to it will be the induced fracture. So not necessary to have them in the same window. So usually we don't see them in the same window. But if, for example, the breakout happened or occurred like here in this example in northeast southwest, then I mean northeast southwest, then I mean the induced fracture will be northwest southeast and so on. I'll not spend too much time here. This is more advancement. We start having more and more applications of, I mean, borehole image. As we started by fractures, as I mentioned, it's one of the most important data owners, operators, they are looking for to understand about the porosity, evaluation, and also the reservoir quality in a broader term. So as we are moving more and more into a smarter solution, I would expect there is a lot of advancement in this scope as well. So the fracture is here. This is like tracing fracture aperture. So it's like having some quantification for the fracture, calculating the aperture is opening of the fracture itself, and it has a lot of statistical criteria to be calculated, taking into account the mud, the mud resistivity and mud density and so on. And then there is a grading for the aperture or the intensity of the aperture itself, if it's like small or big and so on. So if it's like small, it will be like this color, and then you have like a scale for the size of the aperture aperture and itself, and then you can have the aperture selectively in front of each zone, and then summation for the whole reservoir or the whole interval. So this is simply what is fracture aperture calculations. So back again to lumping everything, integrating everything to have like a depositional model, or if we can say one well depositional model. So if we get information about dip data, dip criteria, which is it cross bedding, is it massive sand or shale, laminated, and so on, then we can build fascias, and we can make we can see the cyclic trend and see when I say fascias, I'm not saying sand and shale, because inside sand we can have a lot of fascias as well. So because sand can be massive, pebbly, grade, cross-bedded, and then so this is the kind of fascias. I'm talking about more detailed electropascias, or maybe core-like fascias, if we can say. And then we start having fascias association as well. So based on what we have interpreted from the image, we can make the depositional story. So then we have a channel, and then we have finer cycle for a levee, and then we have the finest cycle, for example, for the overbank and so on. So we can build like single well depositional model, and then link this well with nearby well, and then make like a big depositional model. And this is important details for people work in modeling in general, and they know that FMI is an important step in building a good model, to have the dip meter or FMI interpretation alongside. To conclude, the main takeaways of borehole images, it can be a lot. We can spend a lot of time talking about a lot of applications. I tried here to have like some shaded lights on the main applications, either in terms of structure, fault structures, bedding change, structure dips, and then we talk about the sedimentary features like cross bedding, and then we talk about some texture analysis, or texture identification, secondary, like vagueness, so which will directly say a lot about the the reservoir quality information evaluation. And also we not only geological data, but also mechanical or geomechanical data as well, so related to the borehole shape analysis. When we talk about the in situ stresses impact on the wellbore, so especially for the main criteria for the main two failures we have, and they are challenging, especially in deep drilling, so which is the breakout and induce the fractures. That's all what I have today. I hope it was light, easy, and I hope it will be useful, inshallah, for everybody. And you are very welcome to ask, and I'll try to answer if I know.
Thank you so much, Engineer, for your time. It was an interesting event and webinar. Wallah.
Thank you. Any question, anything in your mind? There is no bad and good and question. So anything in mind, just ask. I think we still have some couple of minutes.
Honestly, Engineer, all was clear. I'm still a student, so I gained a lot. Wallah.
طب الحمد لله. الحمد لله.
Thank you. Thank you.
You're welcome.
Engineer Wael, I have a question regarding to grain size analysis, sorting and baking. We had also a lot of dual VMI, but we can't analysis the grain size distribution, sorting and baking, and some. This is need some special interpretation procedures or processings.
Yeah, thank you for this question. Dual OBMI. Let's firstly tell what is dual OBMI. So OBMI, FMI is formation microimager, usually water-based mud. OBMI, it's oil-based mud imager. Oil-based mud imager. Oil-based mud imager, we are dealing with oil, right?
Yes.
I mean we are dealing with oil-based mud, which like kind of not like the best environment for identifying a lot of features, if we can say. So this tool, it's with time, I think it's already Schlumberger, or SLB now.
Yeah,
so
it's Schlumberger.
I know. So it's it will be, because it was challenging to have a lot of every interpret. To have a lot of details out of OBMI or dual OBMI. So capability of dual OBMI, it's good for identifying structure. Bidding. You can identify bidding planes. You can identify sometimes cross bidding. Fractures, all fractures will appear resistive, will appear wide. You know why? Because it's all filled by oil-based mud. So you cannot say like it's open or closed fracture. But yeah, the capability and the resolution of this dual OBMI tool is not an easy thing to to capture, because the resolution, the vertical resolution, even of it's less than the vertical resolution of FMI. So it's not easy to capture all the grain framework. If you are lucky, you can see some some area. And another thing, it's the coverage of dual of OBMI. So OBMI, when we have OBMI, which is single OBMI, which is cover maybe, let's say, 40% of the well bore, which is not too much. But then we have like dual OBMI, so we have 40 and 40, so we have like almost 80% of the well bore coverage. But if the both of them come together, which is a common problem with the dual OBMI, so you will not say. You will find these columns come into each other, so it's not easy to have. To to go more into like very detailed interpretation. So it's maybe enough to identify bidding if it's there. Sometimes it will struggle in identifying the high angle features as well. So because as more as you want to get like very detailed interpretation, you need firstly a good resolution to support this detailed interpretation. If you have a good quality image, good quality oriented image, so then you can come up with a lot of detailed interpretation. And unfortunately, if you have like a limited quality piece of data, then it's not easy to capture a lot of fine detailed information.
Yes, it's a challenge. Yes. Thanks, Engineer Wael, for your clarification.
You're welcome.
If there is no further question, would like to conclude the webinar, Engineer Wael?
Yeah. Do you want me to conclude, or do you will?
You take your time. I was just asking if there is no other question.
It's like you're hungry. Okay, I forget that you don't chop bread.
It's done from my side. So I would say that it adds me much honor to be with you today.
The honor is all ours, Engineer.
Alhamdulillah Rabbil Alameen. So, and I hope you got something out of this, and maybe see you in the future, inshallah.
Yes, it was very insightful, really. So thank you very much for this amazing webinar.
You're welcome. You're welcome. Okay, go ahead. You can just close it and